Welcome back to Science Modernizers. Today we are going to continue with the question number 35 of the Nord mock. So question number 36. So we are going to begin with section 2. So if you have not had access to the first video, you can click the link on the description and to access the first video, that is the first 35 questions. So let's get started with question number 35. Okay. Okay, section 2, 10 questions, multiple selections. So we have question 36 to 35. Direction for each group of questions below. 1 or 2 of the responses given is or are correct. Then choose A if 1 and 2 are correct, B if 2 and 3 are correct, C if 1 only is correct, D if 3 only is correct. So the directions are summarized on the table. A if 1, 2 only, B if 2, 3 only, C 1 only, D 3 only. In such questions, you have to know your basic concepts in physics so that you should not be led into error. Question number 36. A particle is acted upon by a force of constant magnitude, which is always perpendicular to the velocity of the particle. Which of the following is or are true if the motion of the particle takes place in a plane? 1. Its velocity is constant. 2. Its kinetic energy is constant. 3. It moves in a circular path. Now, what does this statement here describe? So that actually describes a body which is moving in a circular path. Now, what's the direction of the force? We have a centripetal force which is always directed towards the center of our circle O. So here we have the centripetal force. And how is the velocity? The velocity is always tangent to our circle at all points. We have tangents to our circle. So you see that the velocity is not constant throughout, but the speed in circular motion is constant, because over time, as the object is moving, the direction of the velocity is changing, so it is not constant. But since VR is not constant, but the magnitude of the speed is always constant. Now, since the magnitude of the speed is constant, it will imply that the kinetic energy is constant, since Ke will be equal to a half mv squared, and v is simply given by omega r, so kinetic energy will be a half m omega square r square, and that's a constant, and it moves in a circular path. So we see here that only option 2 and 3 are correct, so the correct option here is B. Go to the next question. 37. A small ball starts moving from A on a fixed track ABC as shown below. Surface AB has friction, and the surface AB has friction, and the ball rolls through AB without skidding. Surface BC is frictionless. KB, KA, KC are kinetic energies of the ball at A, B, and C respectively. So 1, HA is greater than HC, then KB is greater than AC, HA is greater than AC, KC is greater than KA. Next is HA is less than HC, and KB is greater than KC. Now it is true from here we see that the height HC is greater than the height HA. Now let's verify this. Now we are going to conserve energy, and conserving energy here, as the ball is holding on a frictionless they said there is friction, so it means that this is going to have a certain amount of kinetic energy as it is rolling down, and as you roll down there is a certain amount of energy which will be dissipated backwards, and that will be the energy due to frictional forces. And then we are also going to have its potential energy. So from the conservation of energy, the energy of A the energy at A is equal to the energy at B, which is equal to the energy at C. Now the energy at B is simply the kinetic energy, and that's where kinetic energy is maximum. At no other point will the kinetic energy be maximum, because so long as we are moving, since for example at C, the energy at C will simply be mg times hc plus a certain kinetic energy at C. Now, but what do we know? You see that from this equality, we can now have that kinetic energy at B will be equal to mg hc plus kc. Now, you see that this energy is equal to the sum of two different energies, so it definitely means that kb should be greater than kc. So that's a way of analysis. And you see from here that the hertz, hc and ha, hc is greater than ha. So what do you observe? If hc is greater than ha and kb is greater than hc, it means only 3 is correct. And if only 3 is correct, what's going to be the correct option? D. Okay, next question. The next question is, a ball hits the floor and rebounds after inelastic collision. Which of the following is true? The momentum of the ball just after the collision is the same as the momentum of the ball just before collision. The total momentum of the ball and the earth is conserved. The total energy of the ball and the earth is conserved. So which of these is correct? Is option 1 correct? The momentum before is equal to the momentum after? No, because there will be a change in direction. So you see the ball is falling, and since momentum is a vector quantity, the direction will definitely change, so momentum is not the same. But the total momentum of the ball and the earth is conserved. True. The total energy of the ball and the earth is conserved. True. So option 2 and 3 are correct. Correct option B. Number 39. Photoelectric effects supports quantum nature of light because 1. There is minimum frequency of light below which no electrons are emitted. Is that true? Yes, and we call that the threshold frequency. If you have problems on photoelectricity, the link to photoelectric effects will be dropped at the level of our description, so you can click and watch the video. So the threshold, the frequency of the incident radiation should be greater than or equal to the threshold frequency in order for electrons to be emitted from the surface of the metal. Now the next, so this is a correct statement. The maximum kinetic energy of photoelectrons depends only on the frequency of light and not on its intensity. Is that true? So let's verify that. If you have a metal surface, let's say we have a metal surface and we have light which is incident and electrons are ejected, the energy of the incident radiation is equal to the work function plus the maximum kinetic energy. So it means Ke max will be equal to the energy of the incident radiation is HF minus the work function which is HF0. So you see clearly that the maximum kinetic energy depends only on frequency and not on intensity. So B is correct. Now 3 says, when illuminated, when a metal surface is faintly illuminated, photoelectrons leave the surface after some few seconds. No. As you illuminated, you leave electrons instantly, provided that F is greater than or equal to F naught. So option 3 is not correct. So 1 and 2, A. Number 40. A wave equation which gives the displacement along the y direction. Which gives the displacement along the y direction is given by y is equal to 10 to the negative 4 sine 60t plus 2x, where x and y are in meters and t is time in seconds. This represents a wave of wavelength pi meters, frequency 30 Hz, traveling with a velocity of 30 meters per second in the positive x direction. So what do we have? We have that our y is equal to 10 to the negative 4 sine 60t plus 2x. Now we can compare this with the general equation of a wave. We have 10 to the negative 4 sine. Okay, I will write it as omega t plus phi. So you see, so our amplitude here is 10 to the negative 4 meters. Our omega is equal to 60, but omega is 2 pi divided by the frequency. So 2 pi f equal to 60. So from here, frequency will be 60 all over 2 pi, which is 30 on pi. So hertz, so it means frequency here is correct, option 2 is correct. So it means one of those should be correct. Now the traveling velocity at 30 meters per second in the positive x direction. The sign here is positive, so it means it's traveling in the negative x direction. So this is wrong. So definitely, since 2 is correct, 1 should be correct. So let's verify that. Now if you compare, phi is equal to 2 pi x divided by lambda. So if you compare this and this, you have that 2 pi on lambda will be equal to 2, and that's true if only if lambda is equal to pi. So it means pi meters. 1 and 2 is correct, option E. Number 41. A satellite is moving in an elliptical orbit around the Earth. The mass of the satellite is very small compared to the mass of the Earth. 1. The acceleration of S is directed towards the center of the Earth. True. The total mechanical energy of S varies periodically with time. From the conservation of energy, the total mechanical energy in a system is constant. So 2 is wrong. Automatically 3 won't be correct. So 1 only, C. Number 42. A ball just hits the floor and rebounds after inelastic collision. So a similar question like that above. In this case, the mechanical energy of the ball remains the same in the collision. Is that actually true? No, because some heat will be lost. So energy will be lost either in the form of heat, sound, frictions, etc. The momentum of the ball just after the collision is the same as that just before the collision. This statement is not true, as we saw above. The total energy of the ball and the earth is conserved. Correct. So 3 only is correct. So the correct option is D. Number 43. Capacitor C1 of capacitance 1 microfarad and capacitor C2 of capacitance 2 microfarad are separately charged fully by a common battery. The two capacitors are then separately allowed to discharge through equal resistors at time t equals 0. The current in each of the two discharging circuits is 0 at t equals 0. That is not true. I is equal to I naught times e to the negative 2 t, where 2 is 1 divided by ROC. So that's not true. When t equals 0, I is equal to I naught, which will be equal to V on R. So what do we have? So that's wrong. Next, the current in the two discharging circuits at t equals 0 are unequal. Correct. So since 2 is correct, 3 should be correct. Capacitor C1 loses 50% of its initial charge sooner than C2. Definitely. Why? Because the capacitance of one doubles the other, and Q is equal to CV. You see. So since this for Q2, let's say this Q1 is equal to C1V, Q2 be equal to C2V. Now since C2, what do we have? C2 is 2 farads, so that will be 2C1 times V. So that's Q2. So it means C1V will be equal to Q2 divided by 2. So definitely it should be halved. So the capacitance C1 loses 50% of its initial charge sooner than C2 loses 50% of its initial charge. So 2 and 3 are correct option B. Number 44. A current carrying infinitely long wire is kept along the diameter of a circular loop without touching it. The correct statement is OR. The EMF induced in the loop is 0 if the current is constant. That will be true. The EMF induced in the loop is finite if the current is constant. The EMF induced in the loop is finite if the current decreases at a steady rate. No. If the current decreases at a steady rate, diffusion will be 0. So this is wrong. This is wrong. 1 only is correct. I think that should be C. 1 only is correct. That should be option C. Question number 45. The graph between the stopping potential V0 and 1 on lambda are shown in the figure. Phi1, Phi2, and Phi3 are the work functions. Which of the following are correct? Okay, so we have the values of the work function. Okay, so we want to verify that Phi1 is to Phi2 is to Phi3 is 1 is to 2 is to 4. Now, is that true? Now, what is the work functions? Their respective work functions are here. We have 0.01, 0.02, 0.04. So if we take the ratio, 0.001 is to 0.002 is to 0.00004. What do we have? That will be 1 is to 2 is to 4. So 1 is correct. The slope of these graphs are the same. Correct. Normally they should be the same. So this should be this will give the same thing, because from the equation E is equal to, or let's say HF is equal to, HF is HC on lambda. That will be equal to HF naught plus KE max, which is E times the stopping potential. So the stopping potential will be equal to HC on lambda minus HF0. All of this on E, all of this on E. Now you see that the gradient for all the graphs will be the same, which is HC divided by E. So the slope of all the graphs will be the same. So 1 and 2 are correct. Correct option E. Section 3, 5 questions. Each of the questions 46 to 50 has 4 sets of graphs A to D. Which graphs of each in each question best fit the relationship between X and Y? Now the stopping potential for a metal versus the wavelength of the illuminating radiation. So we have already seen just from the question above, so it's A. It's A. From this question 45 is A. Okay, so question number 46. The image distance for a convex lens versus the object distance for the lens, for the convex lens. So what are we going to get? Now we know that 1 on F is equal to 1 on U plus 1 on V. So you see 1 on V will be equal to negative 1 on U plus 1 on F. So this is the sort of a distance, the distance of reciprocals. So the best option here will be option B. Now number 47. Okay, question number 47. The potential energy of a simple pendulum versus the displacement. So in this case, how does it vary? Now we are going to use the graph of total mechanical energy. So it is something of this sort. Potential energy goes like this. So that's the origin O between negative A and A. So what do we have? So here we see that the only correct graph will be D. So taking it just from 0 upwards. So the correct graph is D. Number 48. The range of a projectile at a fixed angle versus the velocity. What's range? Range is your U of x times the period. So if you are plotting the range versus velocity, so it definitely means you are going to observe a straight line graph passing from the origin. So it's going to be B. Number 49. The impedance of an inductor in an RLC circuit and frequency is A. Then the pressure of an iodine gas at constant volume versus absolute temperature, PV is equal to nRT. So what are we doing? The pressure of an iodine gas at constant volume. So you see that since P is constant, will be nR divided by V times T. So P will be equal to a certain KT. So it's a straight line graph passing from the origin B. And that brings us to the end of this video. Thanks for watching. Do not forget to like, share and subscribe.